All right. Well, I'd like to thank everyone so much for joining today to another Balerion Space Ventures podcast. It's April 27th, and today we're joined by Paladin Space and founder and CEO, Harrison Box. Harrison, thank you so much for being here.
No worries. Yeah, thanks for having me. Love talking about this problem. So I'm all ears to all the questions you've got.
No. So, what you guys are doing at Paladin Space is in orbit debris removal and the first reusable satellite to do this. In a high level,
Hmm.
how would you explain this to someone who maybe doesn't know what the problem really is and why the solution is so important?
Yeah, it's a good question. I mean, space debris is something you kind of hear about in the news, but in real life context, what does it actually mean, and how bad is the problem? For example, I think one of the things I'd love to start by saying is that when we're talking about space debris, we're talking everything from the smallest pieces that are fragments from collisions to big, large dead satellites. But in essence, space debris is just man-made junk that we've put in orbit essentially. And like we do on Earth, we leave litter around on the floor. Like the thing with space is that when you create space debris, it's persistent. It will last for years, decades, hundreds of years, depending on the altitude. And even the smallest pieces of debris can cause catastrophic collisions because something even this size here, which is about 3 centimeters, 1 inch, can cause the same explosive impact as a landmine. So what we're seeing in orbit at the moment is quite literally a minefield. And right now, space operators are avoiding these pieces of debris all the time. And one of the things that I like to tell people as to why they should care. I mean, they're living their life on Earth perfectly fine without knowing about space debris, but we rely on so much infrastructure on Earth from space without realizing it, even contactless card transactions and GPS. So something the size of what I'm holding here, which is only a few centimeters, could start rendering these space assets that we rely on, that critical infrastructure, to be gone and would be entering back into a dark age. So what we're doing at Paladin Space is solving that by providing the world's first most scalable solution that's multi-capture to get rid of this problem. But right now there's about 9,000 tons of this stuff already in orbit. And right now the industry is poised to grow, triple in size by 2030. So if there's already 9,000 tons of debris, it's only going to get worse.
And this 9,000 tons of debris, this is all things that are rendered useless in space, not active satellites.
Absolutely.
Wow.
Exactly. Yeah, just dead stuff in orbit that mankind has created. And yeah, it's just it's funny every time I talk about this problem, every number I give is always the best case that it's going to ever be. It's only going to get worse over time, which is crazy.
Wow. And we have over 10,000 satellites in space right now. And this is growing so exponentially. It's going so fast. How are we able to manage this minefield, as you call it, today?
Well, there's already some really great work going into deorbiting systems, so that when the satellite reaches the end of its life, deployable drag sails will pop out, or they'll reserve a small amount of fuel on board to actively deorbit the satellite when it reaches the end of its life. And it's great to see so many satellite operators taking these measures, partly in turn because there's regulatory environments that try and stipulate that at the end of your life, you've got 5 years to deorbit your satellite. Now, this is all very good and well, but what that doesn't protect against is random fragmentation events or if you've been hit by debris. You can have all the world's best deorbiting measures in place and the world's best engineers to do that. But once you get hit by a piece of debris and you've fragmented, like we've seen with that recent Starlink that was fragmenting in orbit, all of a sudden the ability to deorbit yourself is gone. And you just suddenly now have become debris, or actually more likely you've become fragments of debris that are no longer controllable. So it's interesting scenario we're finding ourselves in because there's not so much engineering you can do to protect against that. So that's why we're here to remove those threats.
Can you walk us through what it looks like removing these threats in orbit? Like, what's happening
Yeah.
there? Is it going and grabbing something? What does it do after it has it?
Yeah, absolutely. I mean, there's a slide I can probably share that helps
Sure.
to explain what we do. But if I present my screen, that'll come up okay with everyone else on board online. Hopefully
No,
that'll be okay.
absolutely.
Awesome. All right. Hopefully, everyone can see this screen then. Does that look okay on your end?
Yes, yes, I can see it.
Brilliant, awesome. So what we're doing with Paladin Space at the moment is building the payload, the world's first multi-capture system that can collect not just one, but multiple items of space debris in a single mission. But to do this, of course, we need a satellite to get up into orbit and rendezvous with the pieces of debris. Now, this is what Paladin Space will be working on next year. But what we're doing for the time being is perfecting this capture technology first. So, step one, I'd always say with all these missions is to attach our Triton payload onto a satellite that's capable of doing RPO. Now, what we've done is we've partnered with Portal Space over in the US as our first partner to start offering this debris removal as a service offering, which is really exciting because we're really stoked to be working with that team, and they're offering a satellite bus that can have a very high delta V that can do lots of maneuvers, which is perfect for what we want to do. So what we do at Paladin is we then plan the mission and we say, okay, we've figured out the pieces of debris that are worth removing. And when I say worth removing, these are the pieces that the customer is avoiding the most. So if they're avoiding this single piece of debris 500 times a week, then that's the piece of debris we'll go after. Because at the end of the day, we want to extend their mission life by saving them fuel. So once we've figured out the pieces of debris worth removing using our own software to do that, we then go up into orbit and we identify the target. So we've built our own computer vision systems using a very novel set of sensors that we'll be releasing more information on the next couple of months. But these sensors will identify which type of debris it is that we're looking at, what the shape, the size, the spin rate is, and even the material type. Once we've identified all those properties, we then move forward with the capture phase, where we then open the doors of our Triton unit. We instruct the satellite to move forward, and then using our patented robotic mechanism, we capture the piece of debris. Um, Sounds much simpler than it is, but in reality, we've developed technology that can capture debris that's any geometry, any spin rate, doesn't matter what axis of spin it's in as well. We can capture it while it's moving. And really, any sort of size, as long as it fits inside our unit. Once we've pinned it inside our unit, it will not move. And we get to go ahead and repeat this process with any new pieces that are in the vicinity. So any other pieces of debris that are in a similar orbit to the one we've just captured, we instruct the satellite to move to the next piece, and we just repeat that process. My favorite stage of this whole mission is, in fact, the disposal phase. This is an animation we've taken from the website in case there's any keen eyes among you. But what we do here is we dispose of it by ejecting the payload from the satellite. So the Triton unit is ejected. In this animation, you'll see it has a destructive re-entry, which means it burns up in the Earth's atmosphere and it's gone. But really, the key here is that the satellite remains in orbit. And this is fantastic because if the satellite has five other payloads for five other missions, it can continue doing that. This is really just our first market entry route of disposing of the Triton payload. But what we really want to do, and the reason I built this company was not simply to remove the debris, it's in fact to start shifting the public's perception of what is junk in orbit and is it in fact a resource. So really for me that the end goal with Paladin Space is to capture this space debris inside the Triton payload and deliver it to an in-orbit recycling station so they can use the contents for manufacturing. It could even be sent to the moon, perhaps, if there's going to be manufacturing facilities set up there. So that 9,000 tons I talked about, I really want to see that as a 9,000 tons of resources that humans can use for more manufacture. So right now that disposal phase might just be a destructive reentry, but it's going to look a lot more interesting in a couple of years. Hopefully that describes a little bit about how the mission works. I can stop sharing so you can we can jump back.
Yeah, it does.
But
And
yeah.
seeing this, the satellite, it just kind of swallows this piece of space debris and then shoots it out in a little
Mm.
box. How many times can this be repeated, and what happens when these boxes run out?
Yeah, absolutely. So we're estimating at the moment, given that it's just under a meter by a meter by a meter in size, that we could capture up to 20 pieces in a single mission using the Delta V on board, especially with portal space. Going forward, we'll of course want to try and develop our own satellites that have refueling capability as well, so we can basically refuel and potentially even restock with new empty containers. So the idea is that we'll send a series of these empty containers into orbit so they can be stationed on a station like the Blue Ring, for example, from Blue Origin. But the idea is that we'll basically have a set stock of these items in orbit that we can dock our satellite to and restock once we've kind of ejected one of these payloads. It depends how the in-orbit recycling aspect will work as well, because if the station is looking for contents and we give them the contents to recycle, the way we've built our technology is that the doors can open and we can essentially push the contents out into the station, in which case we've now got back into an empty container again. We're just reusing the exact same container. So that's kind of a dream scenario for us. I like to sort of describe it similarly to Wally, if anyone's ever seen that film where he
Of
crushes
course.
all of the debris and pops out. Yeah, there you go. Drew a lot of inspiration from that film. But yeah, so similar to that.
And when I'm thinking about this, you're having to, track down all these pieces of space debris. It makes me wonder of how you think about propulsion versus endurance versus payload trade-off in your system design. I'm sure
Hmm.
you have to use a little bit more propulsion than the average satellite, and the lifespan's got to be long. So, what's the balancing act of all those look like?
Yeah, absolutely. Well, we're really proud of what we've done with this business because we've looked at this business model in a completely different way. You're absolutely right. There's going to be a bit of fuel required to actually remove these pieces of debris. So how do we quantify the value? And what we do, in fact, is we shift the metric entirely away from number of pieces of debris that we remove to instead how much fuel are we saving the customer? And that becomes our entire basis for how we kind of sell this to uh, mega constellation providers or even potentially space station providers. What we do is we say, okay, if you're avoiding these pieces 500 times a week or 10,000 times a year, and we save you X number of conjunctions. And by the way, conjunction is a basically another name for a collision event. When you have these collision events, satellite operators have to move out the way, which means you use fuel. So what we say is we're going to save you X number of conjunctions a year, and that will save you X amount of fuel, which will extend your mission life across your entire fleet by this percent. And that's very quick that we can figure out how much money that saves them because you can very quickly figure out how much money they're saving and not having to replenish their fleet, how much money they're having to save by not having operators on the ground having to make these collision avoidance maneuvers. And all of a sudden, we've got this dollar value that we're saving them every year. And as long as we pick debris that makes that dollar value work, then everything's happy. And so, of course, for us to remove one piece of debris they're avoiding 500 times a week, we're using a bit more fuel to remove that, but we're saving them a lot more in the process. So it's kind of an interesting way that we go about this business model. And of course, depending on who we speak to, there's different value benefits. There's mega constellation providers might care more about their bottom line, about how much fuel life they're extending. But if you go to a space station provider, and this is partially why we've got an LOI from Starlab, is that we're offering them more than just fuel life extension, but actually protection of their human astronauts on board. And this is quite a big aspect of what we do here is that we can kind of tailor what we do to sort of attack different benefits. I mean, defense might care more about threat mitigation and removing threats that can make certain orbits unusable, and that means more to them than just how much fuel they're saving per year. So it depends on who we're speaking to. Then there's the
True.
whole insurance market, and that's a whole other angle as well. So it's depends on who you're speaking to.
And I saw a question here from the chat. Is there a risk of someone else claiming ownership of the space junk and preventing you from removing it? Thought that was interesting.
Yeah, it's a really interesting question. I was actually talking over at the United Nations in November on this topic because there's a rising tide, I suppose, of requests for transfer of ownership. And this concept is where you go up into space, you can identify the target is what you think it is. And as long as you're transparent in your operations and how you go about removing space debris and you kind of tick all these boxes, there's this basis for being allowed to transfer the ownership from whoever owns the fragment to the company that's planning to remove it. And this is really important because actually, whoever asked that question touched on a really good point that the way that the current legal system stands is that if you capture that piece of debris, it still is owned by the previous person who launched it. And this becomes quite muddy because if you've then caught this piece of debris, it's still owned by that member state. If you then use that piece of debris and create a collision, then who's liable? And that's where it gets a bit more tricky. For the first few missions that we plan to do, we plan to capture debris that's from the states in which we've launched from. So if it's US or UK or Australia, because we're company that's based across the UK and Australia. But our partner with Portal Space is over in the US. So we'll probably be capturing debris within those three jurisdictions, and we'll just work with the regulation authorities to make sure that we're doing everything above board. But the way that the laws are being shaped around this, they're progressing in a really good way. That's allowing space debris removal companies like us to operate with a bit more autonomy, which is fantastic.
And the space debris that's, able to fit in a 1 cubic meter box, and
Mhm.
it's dead debris. There's no like contact with
Yeah,
it. It's not a GPS of any kind. Like, how are we
especially
able to
fragmented
tell?
debris.
Yeah, how are we
Yeah.
able to tell whose is whose? How are we even able to detect what this is and where it is?
So right now we rely quite heavily on tracking companies out there, SSA companies that are constantly monitoring these pieces of debris and tracking where they are. When there's been a collision event in orbit or a fragmentation event, these companies are really quick to start figuring out whose is who. Now, of course, there's always going to be a bit of uncertainty with that, especially if two satellites collide and there becomes a fragmentation cloud of debris. I mean, how at that point do you figure out which one's which? And in fact, you've touched on a good point because this is part of the basis for why transfer of ownership is a really essential thing that needs to happen because the reality is no one's going to know, whose is who if there's two exactly the same satellites from two different countries hit each other. It's really important just to demonstrate that it is in fact inert and it is in fact not an active satellite or it can't become an active satellite with a small repair. So luckily with the type of debris that Paladin Space is going after, that fragmented debris, we've got a really good case for being able to demonstrate it is, you know, it might not even really necessarily matter who it belongs to. If it's this fragment that's this big, that's a fragment of a piece of metal, that is worth removing and it's not going to cause any legal problems. But it's a good point. Part of our imaging system that we've built is around trying to identify the ownership, and that can be from small things like writing that's on the panel, the type of material, and then we'll cross check that with what the satellite architecture was when it was launched, so we can start kind of piecing it together. But it's a tricky problem. It's a tricky problem to solve.
Sure. And
Mm,
your first customers, what does this look like? This defense
mm.
is this defense agencies? Is this commercial first?
Yeah.
What are the applications here? Who wants to, get these services first?
Yeah, well, there's probably four really key markets that we're looking at the moment, and we've got LOIs from each of these four markets. So it's really going to be a race to who we kind of target first. But we've got mega constellation providers who have got the most benefit from a fuel saving perspective. So the classic Starlinks, the Amazon Leos, the Eutelsat OneWebs, who are constantly avoiding lots of pieces of debris, especially in that highly congested LEO regime. So we've got a few LOIs from them, and that's potentially what we're going to look to try and target first. We've also got LOIs from space station providers, and that is a very kind of serious thing that we're wanting to do to improve astronaut safety. But noting, of course, space station providers won't be around for another couple of years. And then if there's defense, and we've got a couple of LOIs from them too. And defense is a really, really interesting aspect for us. I mean, of course, you guys are very familiar with the Golden Dome. Who isn't? But with defense, one of the really interesting things is that we're starting to notice that space debris removal isn't just a peacekeeping mission to make space more sustainable and accessible. We're actually starting to see that space debris can be weaponized. And of course, we're not trying to say that Paladin Space would weaponize space debris, but what we're saying is that adversary states can very simply fragment their own satellites, whether that be through an ASAT, which is an anti-satellite missile, or whether they intentionally have something on the satellite that enables it to fragment. And this is really interesting because those fragments can then render a certain orbit unusable, inaccessible. And these can be very critical orbits that potentially US defense want to be operating in. And what we want to try and provide at Paladin is a kind of a threat mitigation, emergency disaster response system that can go up there quickly, remove these threats from orbit before they create what's called a Kessler effect, which is a cascading series of collisions. You're nodding. I'm hoping you've heard of that before, which is great. Which is, you see one collision creates other collisions, and all of a sudden you've kind of got kind of a chaotic situation in orbit where you can't operate. So for us, we're looking at systems like ours to try and remove that threat before it kind of turns into that scenario. So for defense, that's most likely going to be our first play. So yeah, who knows? With the way that defense spending is going in space, it might likely be that one. Last market is insurance. And so we've had a few insurance firms talk to us about this way of risk mitigating for new clients, especially ones who want to operate in LEO. Um, an interesting aspect with insurance too is we've built a software tool that can predict and forecast collision avoidances. This is an internal tool that we built at Paladin to use purely for mission planning. What we didn't expect is that this tool would actually have a bit of value to insurance providers looking to understand risk profiles of new clients. If you can type in the client name and figure out how many conjunctions they're making for the next year, but then how many would they make if they had 100 satellites or 200 satellites in similar orbits, we can model that. So this is actually a potential other product that we are going to start licensing in probably next couple of months. So who knows? Sorry to answer your question with such a long-winded answer, but
No, I
it
like
does
it.
depend which one comes first.
And I
Yeah.
do want to touch more on the Kessler syndrome, because I feel like you might know a good amount about this and be very well studied on the subject. What does the Kessler syndrome look like in actuality? It's satellites that collide, that create debris, that hit other satellites, and it's this chain reaction. It's a very scary idea, and I want to get a take from you of what that would actually look like if it were to really happen. Do we have anything in place to prevent it right at the start, or would we have to focus on, how are we going to clean this up once space is just chaos?
Yeah, so okay, well, how it works and how it looks, I would like to describe it a little bit like nuclear fission, where you can have separating pieces of atoms, from one collision. And for us, yeah, there's papers and studies to show that potentially this has already started, the Kessler effect. Now that's a very scary possibility. I can't weigh in on whether I agree that that is the case, but it is already becoming a lot worse than we predicted. A really interesting stat I like to tell people is the thing called the crash clock. And I'm not sure if you've heard of it before, but this was back in 2018. There was a paper and a study showing that if every satellite in orbit stopped making a collision avoidance maneuver, there would be about 160 days before there was a collision. That number is now 3.8 days, and that was last year. The crazy number for me there isn't the fact it's 3.8 days. The fact is that it went from 160 to 3.8 in only, you know, 5, 7 years. The scary thing about that is that our industry is likely to triple. As you said, we've got about 10,000, 14,000 satellites in orbit. That's going to be 30,000 in a couple. It's going to be 100,000 in 5, 10 years. That number, if it's already 3.8 days before a collision happens, is very scary because there's a lot that could go wrong there. And when the collision like that does happen, it will create those fragments, which then create more collisions. And what that realistically could look like for the Kessler effect is that we could be talking an entire fleet goes down, or at least an entire orbital shell of satellites goes down. And that's, yeah, very scary, scary, scary thought. Hard to really kind of quantify the level of damage that would create, but especially in LEO. And we were talking a lot with ODCs recently. I think that's a very hot topic. I don't know if you've had any podcasts on orbital data centers yet, but that's going to be a huge amount of infrastructure being placed in orbit. And one Kessler-like effect scenario, you could be talking about billions of dollars being wiped off orbit. So scary scenario. Of course, I don't want this to happen, but at Paladin, our whole mission aim is to remove these fragments so that that doesn't happen. And if there is the beginning of a Kessler effect and there is unfortunately a collision, time is of the essence. So we want to be the first to be quickly up there, remove those fragments before they create more collisions, and save the infrastructure.
Yeah, and I'm thinking about this, and you mentioned space warfare earlier, and the
Mm,
idea of that, of maybe kinetic vehicles going and destroying adversary satellites. Um,
yep.
it just seems like not worth it, to the point of, blowing up a satellite that's going to create a lot of debris going out in all directions.
Mm,
I'm sure militaries have taken this into account. So Is that still on the table for what space warfare could look like, or is it going to be a little bit more sophisticated of maybe satellites grabbing each other, or maybe a satellite like yours that's able to just swallow up an entire adversary satellite or grab onto it
Yeah,
and then shoot it into Earth and have it burn up in the atmosphere?
absolutely. I definitely think there's a plausible case for all of those scenarios, perhaps all at once. There'll be cyber
Oh,
warfare to jam the signals, then you'll have a satellite do some dogfighting and grab it and move it or nudge it or intercept it. And then you could have much more chaotic approaches, like just simply fragmenting your own satellite and using the fragments to destroy others. All are very possible. The thing I'll say about the last one with fragmenting your own satellite, it sounds terrible, it sounds chaotic, and sure, it could cause damage to your own sovereign satellites by doing so. But the really interesting about that aspect about that approach is that it's perfect for plausible deniability. And that's the very scary aspect. If you're dogfighting with someone else's satellite and you're capturing it, you're very clearly on record committing an act of war. Whereas if your satellite were to accidentally, in inverted commas, fragment, then that was simply an engineering fault. What could you have done? It was a battery cell that ruptured, and you could never have predicted that was going to happen. But oh no, those fragments then took out four US spy satellites. And that's the really kind of scary aspect is that plausible deniability. It's an act of war without actually being an act of war. And so that's something we're trying to protect against. But I think we're going to see all kinds in the next couple of years, which is very, very terrifying, but very interesting to see how, the Golden Dome shapes up and how that resiliency is built across all these different countries to protect against that.
and when you said the it could just look like an accident when clearly an act of war was happening. It made me think of another idea of in Star Trek, the Starship Enterprise, they have a self-destruct button, a last resort. So
Yep.
if an adversary puts up a satellite to do harm and then faced interference of satellite coming along to try to grab it and prevent it from doing
Mm.
harm, it could
Mm.
essentially blow itself up and then say play victim. And
Yep.
you kind of start playing this chess game of who's really at fault, who's at blame,
Exactly.
what's going to happen, who's going to tip over that first domino to set off this chain reaction that eventually becomes the Kessler syndrome. Have you talked with the government agencies about like this high level strategy of how you got to start playing this three-dimensional chess?
Yeah, absolutely. We're in quite close communication with the US Space Force, and we're talking with different kind of war game scenarios. There's a few really good things. I love how progressive US Space Force is, and the UK MOD is really great for this as well, running war game scenarios where they have companies like ours participate along with other ones that we model kind of fake scenarios like this and how quickly can we respond? How would we respond? How effective could that be? And we kind of run these simulations. We're talking with them at the stage. Probably can't share more than that, but
Sure.
um, what you do about those scenarios is really complex. Yeah, it really depends on so many variables, but it's quite interesting. It sounds like this whole podcast is becoming like doomsday prepping, but that's but yeah, it's very fascinating to kind of figure out what we can effectively do. Um, so yeah, sorry, dancing around that question. It's so convoluted. It's
It
very secret.
definitely convoluted, secretive, absolutely interesting. That's for
Mm.
sure. And so I'm thinking about this as you scale up, what is that going to really look like? And if there was an emergency, is there like an emergency like hyper scale up plan? I'm
Yeah,
I'm kind of curious where you're at today and where you expect to be in 3 years if things are good, 3 years if things
yeah.
are bad, which might be good for your company. Maybe that's a bad way to put it.
Oh, Christ, it doesn't sound good when you say that, doesn't it? It's like it's not like we want a
No, no.
bad scenario to happen, but anyway, I've noticed that something interesting about the way humans work in society is that we're very reactive as a species and not very proactive, unfortunately. We like to, we notice some bad things happening, but until there's a big event that happens, that's, when it kickstarts a lot of change. We want to try and promote the change before it has to happen like that. We don't want the space station to be hit and astronauts to be in danger. But if that were to happen, it would kick this industry into gear, um, and create a bit more demand. But where I see ourselves in the next couple of years, I mean, just right now, I'm calling from Australia. It's currently 1:30 a.m. or 2 a.m. if there's anyone from Australia tuning in. But we also have an office in the UK that's sponsored by funds from the European Space Agency and the UK government. We also then plan to enter into the US at some point soon as well. But where we want to see each other ourselves in the next couple of years is, in fact, having multiple Triton units attached to, I mean, Paladin satellites, perhaps, or at least Portal satellites at various launch sites around the world. So what we want to see is basically the capability to launch these things on a dime. You might have heard of the Victus series of missions that Rocket Lab is working with the US Space Force on. But one of them is Victus Haze, and that's a mission that shows if Rocket Lab can pull this off, it would show that they can rendezvous with a target in 72 hours from, from the first message being sent to launching a satellite and getting into orbit within 72 hours. If that can be demonstrated effectively, we can show that we have the ability to have responsive space operations. And if there were Paladin Space satellites with Paladin Triton units that can be quickly injected into orbit to respond to an emergency scenario, whether it be a defense related scenario or perhaps just a simple cleanup mission, then it shows that this can be a kind of a scalable solution to the problem. So yeah, that's where we see each other in the future is multiple launch sites around the world stocked with our satellites ready to go on a moment's notice. That's the dream.
And just thinking about the future of who's going to be in space, do you think that space is becoming more centralized or more decentralized? What I mean by that is centralized, just several very powerful actors that control most of it, versus the latter, which is many capable players operating in space.
Mm. So I think the way we're seeing it at the moment, it's becoming a lot more globally accessible space. I mean, for example, when I was at the United Nations, we saw a lot of great things coming out of Africa, in fact. So I think if I was going to hedge my bets right now, I'd say South Africa is becoming a new space hub. The next, I think it was the Sustainability Forum. I think the next one's going to be in Brazil. There's some really great places starting to pop up around the world that, once were kind of smaller and are now growing quite rapidly. And because of the cost of access into space is dropping significantly, I think that's going to just open the doors to loads of new markets. So yeah, we'll keep an eye out, I guess. But I think we're quite well positioned, Paladin, to be in the UK and Australia because we fit under that AUKUS trilateral agreement that allows us to work quite closely with the US, UK, and Australia with defense related material. I think we're in a really good position across those three countries. But yeah, we'll see. We'll see. I mean, the more people in space, the better. The more infrastructure in space, the better, because for us at Paladin, that gives us more infrastructure to protect. So yeah, very encouraging, very much encouraging the world to get going, which is good.
And as when I think about that, I think of Paladin in space. Um, what does that look like? Is it just their satellites up, uh, constantly going mission to mission, taking care of debris? Are they loitering,
Mm.
waiting for something? Is there a future where, you have these Paladin satellites and they're attached onto the International Space
Mm.
Station or in space data center, very large infrastructure? If it needed
Yeah.
to, go out and protect it against an incoming threat of debris.
Yeah, we plan to have a fleet of satellites in orbit, and the way we plan to do this is a phased rollout. So we'll have maybe a couple of customers to start with. Position our satellites in those congested orbits that remove the most valuable debris for those first customers. But once those first customers, each year we're going to keep using that same satellite to remove debris. As we start bringing on more customers, we'll put other satellites up into other more congested orbits that satisfy those. And soon we're going to start having a proliferated presence across lots of different orbits. And if these satellites are built to be refuelable, which is the intention, then we have the ability to just keep operating and to keep reducing our costs while providing more benefits to customers. And that's the dream. And you're absolutely right. If there is a terrible scenario that needs us to be somewhere very quickly, the idea is that we might already be there. And that's the dream. Worst case, as I said, we'll have Triton units positioned at multiple launch sites around the world. But the idea is that we should already be in orbit, in multiple orbits, ready to go. And you mentioned there as well about having our units stocked on stations. In fact, we were speaking to Starlab about this. This is something that we were talking about potentially having empty Triton units stored on their station so that we can refuel on their station and restock on their station and then go forward. So this is a really interesting kind of uh, role to kind of play in keeping space safe and accessible is to have a fleet-based approach and not just a simple one and done solution. A lot of our competitors looking at removing space debris capture one piece and go down with the ship. But our system is multi-capture, and I think for this kind of problem to be solved in a meaningful way, it has to be reusable. And I think this is the most scalable approach to solving that problem.
In the capturing these items, if
Mm.
there's bigger items that are too big for you to capture, is that still, a challenge that you're up for and something that Paladin could address and take on that challenge, or would you leave that
Yeah.
for someone else?
Well, that's a really good point. There's probably not too much I can share about this at the moment, but
Sure.
we are working on technology that can start tackling some of these larger items. But I like to say in these sort of scenarios that I don't want to ever dog on our competitors. We need those people to remove the large debris, in the same way that they need folk like us to remove the small debris. Because at the end of the day, it doesn't matter if it's a small debris piece or a large debris piece that hits you, it's game over. But we do need each other, and our technology is quite separate about how we go about this. I mean, for one thing, they use a big robotic arm. Our patented robotic mechanism doesn't use an arm to remove the small debris, which is quite special. But it does mean we are limited, of course, to what can fit within our container. So yeah, we need them as much as they need us. But in the future, we probably will start to release some more solutions that can start tackling some of these larger pieces as well,
The
which is
future is looking
exciting.
really, yeah, the future is looking very exciting for Paladin. I want to take it back to the early days. I mean, you're a young company, you've been around for a little over like about 3 years, I think.
Yeah,
And
yeah, good memory. Yeah.
what is it? What
Mm.
does that look like being an Australian company coming up in space tech, where Australia may not be the most, it may not be your first thought when you think of space tech startup. Um, so growing in Australian ecosystem, space tech ecosystem, how you seen that grow, and what was it like that first month, that first year, and how have you grown it into what it is today?
I love that question because I probably should have mentioned. I mean, for those who notice, my accent is Scottish. I'm from Scotland. I moved over from Scotland to Australia to start Paladin Space. And at that time, the government was putting a lot of money into making space um, the new focus area for the Southern Hemisphere. We were going to be the best and greatest and all of this. And there's a lot more focus being put into trying to make that happen in Australia. But one of the greatest things I love about being based there is that the companies that come from Australia, whether you be in space, software, manufacturing, you name it, we have a very good way of ensuring we stay lean. Um, it's not as a capital rich environment as the US, for example, or maybe some other countries around the world, which have larger capital raises and higher valuations and all that kind of stuff. In Australia, we work well with very little. And I love that mentality. And we have a very good work-life culture there as well. So being based in Australia, we've got this ability to R&D very lean, very cheap. We've got a really great community as well. So Australian ecosystem, they all work quite well together. We know everyone who works in space in Australia, so we can lean on each other when we've got a tough manufacturing problem or we're looking for a supplier to do a very niche thing. You ask a friend and a friend of a friend, and then that's it. You've got your supplier. So that's really fantastic. So I want to take that mentality and that way of working when we enter into the UK and into the US. The UK office is great for going into market because they've got a lot more test facilities, a lot more talent in the UK that have been around for a lot longer. Australia's got a bit of a younger space ecosystem, as you touched on. They're not the first country that comes to mind when you hear of space. but it's growing. The UK has been around for a bit longer, and we get to lean on some of that expertise. And then, of course, the US is fantastic, still the market leader in the world. But that's why we're partnering with Portal, and we can kind of get an eye in without having to be based there for the time being. But yeah, it's been a really interesting journey. Being from the UK is good for me too because I've all got all the connections back home, and when I go back and visit the UK office, it's kind of like going home in some ways, which is fantastic as well. We're based over in the Harwell site in Oxford, and I think that that site has over 100 space companies in that one site, which is also great, really useful. But yeah, it's really interesting to watch this space. I think Australia is going to be the next up and coming nation as well, alongside Africa. I think we're going to
And have
be
you,
showing the world, yeah, what we can do.
and would you say you're finding more help or maybe opportunities with the Australian Space Agency rather than the United States Space Agency agencies?
Yeah, for the time being, definitely. I mean, it helps that we're based in Adelaide, which is where the space agency is headquartered in Australia. So, I mean, for us, it's a 5 minute walk down the road to the space agency there. And so that definitely helps in terms of access and chatting to them and getting an understanding with where the agency is heading. I think that's quite a big challenge in the US to understand what the agency is doing, what their kind of plans are for the next couple of years. Of course, you see the white papers and everything, but being able to just chat to someone over a coffee is a really effective way to figure out, what's next on the horizon. So for us, we want to, stay aligned with that. So that really helps being in Australia. I'm thinking in the US is a bit of a different beast. But yeah, I think it's definitely one of the positives of being in this bit of a smaller community.
As I'm thinking about this, I'm thinking the the potential of this industry really being in high demand of space debris removal, especially if things change and it becomes a very serious problem very fast. If a new company, maybe a hyperscaler or someone with a lot of capital came into the market and started trying to do what you guys are doing, what would they quickly learn and have a lot of trouble with, and make it hard for them to compete with you?
Well, okay, quite a few things in fact. So I when I started this company, it's actually based off of research I did back in University of Glasgow. I studied reusable concepts for space debris removal. That was my master's thesis. And when I was doing this thesis, I was evaluating all these different technologies that could be used for capturing space debris and how they could be made reusable so it can be economically viable and a scalable solution to the problem and all of that. I'd say one of the biggest challenges that I found when I was doing that research is that we still don't understand what this debris looks like, especially fragmented debris. No one's ever imaged it before. The only information we understand about this debris is roughly where it is in orbit, and that's through those tracking companies, and roughly what its size is. And that's based on the radar cross-sectional area that comes back from these tracking efforts. Now, this is good. You might understand the radar cross-sectional area, but that doesn't tell you anything about its geometry. It could be a long, thin rod, or it can be a flat panel, and it might have the same cross-sectional area. So whatever technology you're building to remove this debris has to be able to be agnostic of its geometry. Secondly, it has to be agnostic of its spin rate. If you have a piece of debris spinning, which it absolutely will be, typically space debris removal companies, the big large players, for example, as I mentioned, they have those big robotic arms. They have to obviously rendezvous with a piece of debris, orbit it and match the spin rate and then capture it. But for this technology to be scalable and low cost, as you said, there's a lot of fuel involved moving around to capture these pieces of debris. The solution needs to be able to be agnostic of that axis. So when we built this technology at Paladin, when I came up with it, the original patent for the the capture mechanism, it needed to take all of that into account. And I think that's quite a big barrier to entry for figuring out what system can kind of tackle all of that and be reusable. Also, another thing I'll mention is when you capture the debris, you don't want it to move around as well. Just because you've captured it and the door's open, it doesn't then escape. We don't also want it just kind of rattling around inside the Triton container because as the satellite is moving, we don't want the center of gravity to change and mess up the attitude control system. So there's quite a few variables to consider, and then that's before we've even touched on testing. And whatever this system is, it's going to be robotics of some kind. it needs to be able to survive the harsh vibration conditions, the thermal vacuum chamber conditions that you need to have to get into space and pass qualification testing. And I will admit that's no mean feat either. What we did at Paladin is a pretty cool approach. We've taken a bit of a page out of SpaceX's book, which is where we test quickly, we fail quickly, we learn, we iterate, and we repeat. And we took our unit through very, very early qualification testing last year. Even though it wasn't a flight ready unit, we just threw it through vibration testing and TVAC just so we can get an understanding for how this thing performs. And miraculously, it passed the vibration testing. Honestly, we didn't expect that. That was not the plan. We're kind of hoping it was going to fail so we can understand where it's going to fail and just kind of adapt. But anyway, the plan is, we're up on track, which is fantastic. But it's definitely one aspect that's overlooked is robotics has moving parts, and moving parts and vibration testing is not easy. So quite a few barriers to entry. It's a very difficult field, space. But yeah. Anyway,
Absolutely.
so yeah, that's probably some of the aspects I can touch on at the moment.
Changing on topics, you mentioned earlier that you wanted to use, this debris in, you know, having it be reused on the moon for lunar surface to be put into manufacturing. Um, that might be a long ways out, but I'm curious if you could paint a picture in our minds of what that really looks like from
Mm,
you grab something, it's a piece of iron or steel, whatever.
yeah,
Then what? How do you get that to where it's being repurposed and manufactured to build something of purpose at a lunar base?
yeah, I love that. It's actually a really good segue, in fact, from when I was talking about testing and vibration testing, because one of the aspects of manufacturing in space that I'm very excited about is if you're building a satellite in space, in orbit, for example, vibration is not really a concern anymore. You don't have to build this thing to survive those really harsh launch conditions because you're, well, not launching it. It's already there. So for that to work, of course, you need the materials. We bring the materials. The way that would actually look is that if we captured, say, a contorted piece of metal from a satellite structure that had been hit, our imaging system would characterize that as metal. It's a piece of metal. We know what size, shape, and roughly what mass it is. When we're delivering this to an recycling station, they'll most likely melt this down into some kind of rod. There's been some companies already demonstrating this type of technology, like Lunar Industries over in the US. Now, that rod can then be used for a variety of things. In fact, there's another space-based company, sorry, Australia-based company in space that's building propulsion units that use metal as a fuel source for ionizing plasma. Now, of course, they need that metal rod from somewhere, and we collect the metal. Cislunar might make that into a rod, and then they slot that into their propulsion system. Now, how we actually deliver the contents to that space station is interesting. If the station is based in orbit, it's in low Earth orbit or maybe slightly higher, well, the satellite will just take us there. We'll dock with it in orbit. We'll push out the contents from the Triton unit, give that to them, and we just kind of go on our way. If it was based on the moon or maybe even on Earth, and because we actually have built this technology to be able to perform retrieval missions, which is a whole other thing, by the way. If you want to collect sensitive assets in space and actually bring them back to Earth to study, we can build a Triton unit that's just got extra shielding and a deployable drag sail that ejects out the back of the Triton unit as it's starting to burn up in the Earth's atmosphere. Now, that same principle can be applied to the moon. There could be a guidance system on the Triton unit or a deployable sail or something similar that can basically guide its descent into the moon somewhere, and then they can recycle it. At this stage, we're not getting too caught up on that. We're focusing on the disposable aspect of the destructive reentry while keeping in mind that there might be in-orbit recycling stations. The moon will be the next thing to start thinking about. But the great thing about building these Triton units is that they are this kind of really nice rectangular cubic form factor, which means they are kind of easily adaptable to fit into systems. You know, we can put drag sail in the back. We can have hooks around the outside that can dock with um, recycling stations. You know, there's panels we can stick on the side that'll make sure it can survive re-entry. The fact it's cubic means we can attach it to a variety of satellites. So we're trying to make this thing as modular and as customizable as possible, which is good.
And for people who be following Paladin Space. I know I will. Over the next 2 years, what are some like upcoming milestones we should be keeping our eyes out for?
Yeah, well, we've got a mission plan with the ISS to test inside the Bishop Airlock. Once we secure our next fundraise that we're doing at the moment, that'll be booked in for about the sort of January, February mark. So that'll be the next big thing to look out for. And I think that'll be a really fun mission because the way we're going to look at it is astronauts will be throwing pieces of debris at this thing inside the Bishop Airlock and we'll be ejecting it off the station. That'll be a really exciting mission to look forward to. Next big milestone after that will be getting into market in 27 with Portal. So we're talking with a couple of customers at the moment with how that will look. And so we'll watch this space. That will be the next big thing for us. And then, yeah, sky's the limit. I mean, hopefully at that point we'll start seeing more recycling happening in orbit. We can start tailoring to that. But they're the next two big milestones. And then hopefully somewhere within there will be the US office opening as well.
You know, and
Mm,
as the satellite ecosystem grows and there's more and more, what do you think
mm.
we're going to be seeing the most besides Starlinks? Are there other mega constellations on the rise that you think will be, taking
Mm,
up a good amount of space, or is maybe something like the amount of infrastructure from in-space data centers? I guess if we're counting just mass or maybe volume, what's going to be really
yeah.
big in space in a few years that isn't right now?
Love that question. I was actually just chatting to some investors a couple of weeks back. A really interesting number to keep in mind is I think currently, based on the FCC, with the amount of applications for satellites to go into orbit, I think there's 1.2 million satellites that have been applied for to the FCC that are in development. That is a crazy, crazy number when you consider there's only about 14,000 currently in orbit. It just gives you an idea for the scale that we're about to see. And you touched on orbit data centers. In fact, StarCloud, I think, was the famous one that registered for 88,000 satellites, I think it was, for their on orbit data center. We've got AST Space, for example, and although they might not have thousands, might only be 200 or 300 satellites, but each one of them is about the size of a football pitch. So the amount of infrastructure we're putting up there is pretty hard to comprehend. And so when you see kind of these stats of, I think at the moment Starlink is avoiding space debris, well, it must be about 700 times a day. That's currently. And you can imagine what it's going to be once all of these other big players start entering the market and all these other fragmentation events start happening. It's going to be the Wild West. In fact, it pretty much is already the Wild West. But I'd say the next big thing is probably going to be the on-orbit data centers. Um, and yeah, more humans in space, which is fantastic. We're going to see, space stations coming up there and a lot more science experiments happening, drug manufacture, and fiber optics being manufactured in space. I think we're only just touching the tip of how amazing space is and how valuable it can be. And the more we realize that, the more infrastructure gets put up there. It's going to be great. But as I said, a lot more for us to protect, which is also great.
Yeah,
It's
it's an
fantastic.
amazing moment right now, just the amount of scale that this
It
industry is seeing
is.
and how many things are going into space. It's wild.
You can blink and miss it, like it's just like next morning you might wake up and see a new petition for another 100,000 satellites, and it's moving at a pace which is kind of hard to comprehend, which is really exciting.
Yeah. Um,
Mm.
so as we're wrapping up, anyone who's listening to our conversation, if they were to, you know, finish the recording or finish the session and walk away with one piece of knowledge that they learned from our discussion, what would you want that to be for them?
One piece of knowledge to take away from today is that avoiding debris is not the permanent solution. There will become a time where avoiding is simply not possible, and that removal is going to have to be the next step. That's probably the biggest thing I'd say to take away. At the moment, avoiding debris is what we're currently doing, burning through fuel, reducing their mission life, and that is still hurting their bottom line. But eventually, there's going to be a point where they simply won't be able to avoid enough before they just get hit and the Kessler effect will happen. So there needs to be systems like ours before and not just after. As I said, proactive rather than reactive. That's probably what I'd say. Without sounding,
Absolutely.
too doomsday prepping, I want to try and be a bit more optimistic about this. Take it as a good thing. We're here to try and solve the problem, but if we don't, it's a relatively scary scenario.
it's better to fully understand the problem
Exactly.
before rather than try to understand
Yeah,
it while it's happening.
exactly. Exactly. Yeah,
Uh,
appreciate that.
okay. Well, Harrison, this has been a fantastic conversation. I've really enjoyed our time. I want to thank you so much for taking the time to join us today.
Yeah, likewise. I really appreciate the opportunity. It's as I said, it's a problem I'm in love with and happy to chat with it about it. So I really appreciate it. Thank you.
Absolutely. And I want to thank all the participants who are able to sit in on the session as well. Thanks so much. Take care. See you next time.
Thanks,
Bye.
everyone.